In this question, we have returns on stocks and bonds for the last 5 years. We're supposed to calculate the geometric average returns on stocks and bonds. So to calculate the geometric average returns, we need to calculate some helper series. Let's pretend that we start with $1 at the end of 2017, and then we're going to grow that previous amount, in this case $1, at the rate of return on stocks. So that would be this formula here. We're going to do the same thing for bonds. So Control R here. And we're going to then do Control D over here. So if we start with $1 worth of stocks, and we would then end with $1.50 worth of stocks, and with bonds we would actually have less than $1. So the geometric average for stocks would be, and so it would be our A cap T over A cap 0, which is 1. We're going to raise it to nth root, which in this case T is 5 because we have 5 periods. We subtract 1, and I don't know what happened. I guess -1 here, and we get 8.5%. Let's do the same thing for bonds, and let's format this as a percentage. Let's add some decimal places. 8.5 for stocks, minus 2.8 for bonds. That makes perfect sense. At the beginning of 2018, investor A invests $200 in stocks. How much money will they have at the end of 2022? So, we could actually do this. We could actually change 1 to 200, and we would see that they end up with $300. But let's leave it the way we have it, and we can calculate the amount that a buy and hold investor who starts with $200 would have is just the geometric average return raised to however many years they keep the investment in, which is 5 times. So, and it shouldn't be minus, of course, it should be plus. There, plus. That's $300. Fantastic. At the beginning of 2018, investor B invests 200, but then they withdraw 100 at the end of 2021. So let's do that. We need to create a slightly more complicated formula because we've got some money taken out in the middle. So here, let's do this investor A. This is going to be investor B. So investor B also starts with $200. And next year, they're going to have $200. And that's going to grow by 1 plus the rate of return on stocks. And I can just copy that down. But at the end of 2001, this investor will withdraw $100. So their investment at the end of 2021 is well, at the end of 2021. So we gotta really do this in this cell, because at the end of 2021 they had J7 in stocks. From that we're gonna subtract 100 and then multiply that by the rate of return on stocks. And so they're going to end up with $221 in stocks. So they'll have cash of 100. They're gonna have stocks of whatever is in this cell, and total is gonna be $321. What is the dollar weighted return of returns on investor A? So, well, we can actually, why don't we actually put that as, create some series, and we could do it in these cells, but let's actually do it here. So how about this? I'll say cash flows for investor A. Well, investor A starts with 200, and there's no cash flow in between. Only at the end, that investor ends with $300. Investor B also starts with 200. Okay, so we should actually write it as a negative number. So we're going to say minus 200 is the cash flow. And then there's nothing, there is something here at the end of 2021. They're going to have a positive cash flow of 100. And then they cash everything out at the end of 2022, which gives them $221. So let's change this one to minus 200. So these are the cash flows. This is the buy and hold investor. Hey, they have a negative cash flow. They invest 200 and they cash out at the end 300. No positive cash flows in between. Investor B puts in 200 and they take out 100 at the end of 2021 and take out the rest of the money at the end of 2022. So what is the dollar weighted return? We just need to calculate the IRR on these. This is for investor A. Okay, I'll say investor A. For investor B, it's going to be IRR on this cash flow. And clearly, investor A didn't do as well as investor B, because investor A is a buy and hold investor. Their dollar weighted return is the same thing as the buy and hold return up here, 8.5%. Investor B has a better return because they timed it well. They took money out of the stock market right before the stock market crashed in 2022. Fantastic. Calculate the risk on the return on 50-50 portfolio. So let's actually do that here. Let's do 50-50 portfolio. So that would give us 0.5 return on stocks plus 0.5 return on bonds. Let's Control D that. Let's format it as a percent. Let's add some decimal places to it. Yeah, that makes sense. This is really, the return is in between stocks and bonds, exact average. So we want to calculate risk and return. So how about that? Let's do return and let's do risk, STDEV. Let's use a simple arithmetic average, and on stocks, it's this, and standard deviation, use the sample formula on the same range of cells, and let's copy that to the right. So I should probably move this down so that I can label it. So this is stocks, this is bonds, this is 50-50. Is the 50-50 portfolio unambiguously better than a portfolio of 100% bonds? And is it unambiguously better than a portfolio of 100% stocks? So the 50-50 portfolio, well, it has a lower return, so it's definitely not unambiguously better. We have to have a higher return and lower or at least equal risk. The portfolio 50-50 is certainly better in terms of returns than the portfolio on bonds, but it has higher risk, slightly higher risk, but it's not unambiguously better. If these are the three feasible portfolios that we have, are any of them inefficient? Well, let's take a look at the stocks portfolio, 100% stocks portfolio. It has a 10% return with 22% risk. Are there any portfolios that have at least as good of a return with equal or lower risk? No. So stocks is not inefficient. Bonds, that's got pretty bad return. But are there any portfolios that have a lower risk than the bond portfolio? No, there aren't. The bond portfolio has the minimum risk. So if I want to eliminate risk, I'm going to go 100% with bonds. Remember, these are the only three feasible portfolios. That's not that I can keep the money in cash. So it's not inefficient portfolio because it has lowest risk. It's the minimum variance portfolio. What about the 50-50 portfolio? Is it inefficient? Well, it's got 4.5 return. Are there any portfolios that have higher returns and at least as low of a risk? No. Well, there's a portfolio that has a higher return. That's 100% stocks, but it has higher risk. So 50-50 is also not inefficient portfolio. So none of these are inefficient. Okay, so we have two bonds. They're both US Treasury bonds. They both mature in 2030. One bond A, has a 6% coupon. Bond B has 0.6% coupon. We plan to purchase the bonds on May 15, which is on Monday. Assume that the yield on this bond is 3.5. What are the prices of these bonds? Let's get calculating. So what we're going to need is we're going to need maturity date. So, well, sure. Yeah, we're going to need, let's do it up here. Maturity. We're going to need settlement. We're going to need yield. We're going to need, I misspelled yield, but that's okay. We're going to need coupon. We're going to need frequency. We're going to keep it 2. Let's keep it like that. And here's going to be the price. So maturity bond A is it's 5/15/2023. Oops. 5/15/2023. Okay, that's settlement. Maturity is 5/15/2030. And yield we said is 0.035. And coupon is 0.0625 for this bond, and it's 0.00625 for this bond, and the rest of this is actually the same, so we can do Control R on this. Let's format these two guys as percentages, adding decimal place. That's fine. Okay, and now let's calculate price. Is gonna be settlement date is this, maturity date is this, rate is our yield, no, sorry, rate is the coupon, yield is the yield, redemption, let's do 100, frequency 2, basis 0. Let's leave it at that. And Control R. The first bond sells at a premium, $116, premium above par because its coupon is higher than the yield. The other bond has a tiny coupon, so it sells at a discount, $82. Suppose after the yield goes to 4.5, so yield, this time I spell it correctly, is 0.045, and let's format it as a percent, add some decimal places, do it here as well, and let's calculate price. So price is, settlement is here, maturity is here, rate is the same, and yield is 4.5, redemption is 100, frequency is 2, basis is 0. And let's Control R that. Let's say what's the percent change. See, does this look right? I think so. The prices went down. If yields go up, prices go down. How much? Well, let's calculate percent change in the prices. And so that for bond A, and I need to just divide that by this, by the initial one. Control R, let's format it as a percent. Let's add decimal places. So for the first bond, prices dropped 5.6%. For the second, the low coupon bond, prices dropped by more. Why is that? They have the same maturity date. Well, bond B has a longer duration because it has tiny coupon. So you have to wait a really long time before you get your money back. Certainly do that by calculating duration of these bonds. We got a nice formula for that. Settlement is here, maturity is here, coupon is here, yield, sure, let's do 4.5 yield, frequency is 2, basis is 0. You could see that the first bond has a duration of 5.8 years. The low coupon bond has a duration of almost 7 years. You know, this bond matures 7 years from now. Because it has such tiny coupon, you'll have to wait almost full 7 years to get your money back. The duration is much longer, and therefore it's much more sensitive to changes in interest rates. Suppose that yields on US Treasury remain at 4.5. Treasury plans to issue bonds that mature on the same date as all these bonds, but they want to have the face value of 1 million, and they want to raise exactly 1 million, which means that they basically need to sell the bonds at face value. How do you sell bonds at face value? What is the coupon that you need to set? Where do you need to set the coupon to sell the bond at the face value? You need to set the coupon equal to the yield. And we can convince ourselves that that's the truth by saying, well, let's see, what will the price be if, and here's the settlement again, here's the maturity again, and the coupon, well, let's make the coupon be equal to the yield, just 4.5, and the yield is also 4.5. Redemption is 100, frequency is 2, basis is 0. If I am selling, if I set the coupon equal to the yield, the bond sells at par value. Following up on the previous question, following 3, suppose we want to raise more than 1 million. So suppose I want to sell the bonds at higher than the par value. Well, in that case, I need to offer a coupon that's higher than the yield. So let's actually do it this way. Let's say yield, coupon. Let's put in a percentage here. So let's start with 0.05. How about we do 5% coupon? We start with 5% coupon. Add some decimal places, and let's calculate price of the bond. Let's do this again. Settlement is this date, maturity is this date, rate, that's going to be the coupon. We start with 5%. Yield is still 4.5. And redemption is 100, frequency 2, basis 0. All right, so now we're going to sell the bond for 102, but we actually want to sell the bond for 110 because we have a face value of 1 million and we want to raise 1.1 million. So we need to raise the coupon. How about the 6%? Well, that's a little better, but not enough. How about 7%? Well, that's a little too much, maybe 6.5. Yeah, we're getting closer. But so we could certainly do this trial and error, but we can actually do this precisely. We don't have to do it with a trial and error. What do we need? We need the present value of the bond to be $110. And what we're changing here is not the yield, not the discount rate, not the future value. What we're changing are the payments. Okay, we know that we have 14 payments between now and then the bond matures, but we don't know how big these payments are because we don't know the coupon rate. So let's figure out what the payment needs to be. So the payment, we have a financial function for that. If the discount rate is 4.5, that we know that number of periods is 14. We know that PV is minus 110 because that's what we want people to pay for that bond, so that at the end they're going to get face value of 100. Payments are at the end of the period. Payment needs to be, well, actually, I need to actually go back here because these are semi-annual payments. So I need to change the rate is only half of that because that yield is annual, but I want to figure out what are the payments every 6 months. So the rate per period is 4.5 divided by 2. So the payment, the semi-annual payment, needs to be $3.09, which means that it has to be 2 times $3 over 100. This I'm gonna format it as a percentage. It's 6.18. The coupon, the annual coupon rate is 6.18, and I can actually try that. 6.18 gets us pretty darn close to 110. Fantastic. Suppose following up on question 1, instead of buying the bonds on May 15, we're going to buy them on October 15. So let's do a different settlement. Settlement now is 10/15/2023. Okay. And I want to know what the price is, but I'm going to have to also calculate accrued interest because 10/15 is really in between coupon days, because we know that the first coupon day is on 5/15. The next one is going to be 11/15, right? 5 plus 6 is 11. So this is almost through the entire coupon period. So there's going to be plenty of accrued interest that we're going to have to pay to the seller. So the total cost is going to be price, but also accrued interest. So let's first do the price. Price price is, and the settlement is this date. Maturity is this date. Rate is the coupon rate, and yield is saying back to 3.5. That's fine. Redemption is 100. Frequency is 2. Basis is 0. That's pretty good. Let's hit enter on that. Let's control that to the right. We see that the clean price is something different than it was before. So this is clean price. Let's calculate accrued interest. So we need days in period and coupon period. We're gonna need days since coupon. So let's do that. Those functions are coupon BS. That's the days from the beginning of the coupon to the settlement date. That's not the one I want here. I want days in the coupon period that contains the settlement date. And that is, the settlement date is October. The maturity is way up here. The frequency is in my annual basis is 0. Let's hit enter on that. Then we're going to calculate coupon days. Those are days from the beginning of the coupon period to the settlement date. So this is coupon days since the last coupon. Settlement is here. Maturity is here. Frequency is 2. Basis is 0. We're gonna hit enter. Yeah, it's 150 days, really, 5 months. And we can control R that. And now we can calculate accrued interest is going to be 150 over 180 times. Well, times how much? Times 100 times the coupon rate divided by 2. Yeah, because that's an annual coupon and we have a 6 month coupon period. So accrued interest is going to be just this, about $2.60 in the high coupon bond and only 26 cents in the low coupon bond. The total cost or dirty price is equal to the clean price plus the accrued interest, 118, and for the high coupon bond and 83. So obviously the price went up for both of these. Why did it go up? Because between May 15 and October 15, we didn't receive any coupon payments, but we're that much closer to receiving the first coupon payment and all the other payments plus the maturity of the face value. So we're a lot closer to receiving payments. So the present value of those payments is much higher now than it was back in May. Since if the present value of future payments is high, the price of the bonds has to be higher. The price of the bonds went up. Okay, following up on question 5, what happened to the clean prices of each of the bonds after we shifted the settlement date from May 15 to October 15? So let's calculate what happened to clean prices. Well, in the case of the high coupon bond, let's calculate the change. So we can take a look. The price of the bond is here, and let's calculate it as a percentage, although we don't need to do that. So the price of that bond actually went down. The clean price went down, but the price of the low coupon bond actually went up. Why is that? Well, this has to do with accrued interest. Really, the prices of those bonds went, so the total prices, the prices that include total interest, went up. Now, why did the clean price for the high coupon bond actually go down? Well, that's because we owed the seller of the bond a lot of accrued interest. We owed the seller $2.60 in accrued interest. And so we're paying him a lot of accrued interest. In fact, we're paying them accrued interest at 6%. That's accrued interest that's higher than the yield. That's more than what they really deserve, because the yield on the bond is of 3.5%. So in order for us to get compensated for paying this extra yield, the seller will actually need to give us a discount on the bond. And that's why the clean price is actually going to go down. In contrast, the clean price for the low coupon bond actually went up. Why did it go up? Because the accrued interest that we paid to the seller is tiny. It's only 26 cents. We're paying the seller only accrued interest at a rate of 0.6%, which is a lot less than the yield on the bond. So we need to compensate the seller for holding the bond for all this time, not just with accrued interest, but also with some of the yield. Okay, and how do you compensate that seller? By giving him a little more on the clean price. So they're going to sell it to us for a little higher price. They're going to pocket the accrued interest, but since the accrued interest is so tiny, they also need to get compensated by selling it to us for higher price.